Hi all. In this video, we're going to discuss about multimodal language model, various use cases. We're going to discuss about using various data sets like text, audio, video, time series data, etc. So first, we're going to use OpenAI's clip model. It performs image classification just by comparing image to text labels. Therefore, no retraining is required. So install transformers, torch, PIL, and HSPL library and import clip, and then we load the model. We define four images like man cooking, dog in a blanket, and airplane at sunset, mountains, and five text labels. So these serve as classes, and then we visualize all the predictions using matplotlib, displaying the confidence scores. All this is with zero training, and then next we tackle a classic dataset. After that, we tackle a classic dataset with diabetes. So we fit a linear regression model and evaluate using MSE, RMSE, and R square. So the model explains 45% of the variance, which is not bad for a linear baseline. So we can see the data head of the first 5 rows of the dataset. These are the mean squared error and root mean squared error and R squared score. So this is the actual progression versus the prediction progresses. So the true progression value is something around 219 and the predicted progression value is around 139. And this is the tuple of sample features. So next, moving on to wine dataset. We load the wine dataset and use standard scalar to normalize all numeric features. So this is important since k-means is a distance based. And then we run k-means for approximately 2 to 10 and store inertia and Lotte scores. We then plot both to determine the optimal number of cluster. After running it, I got the optimal cluster as k equal to 3. Therefore, we run k-means for that and compare with the actual classes using adjust index and normalize mutual information. And then we reduce to 2D using PCA and plot both the predicted clusters and actual classes. So this visually evaluates how a cluster works. So these are the outputs, and we got the alpha as 3, which is optimal for this case. And the visualization of clusters with the PCA, the true and versus the predicted ones. And then after we're gonna deal with the text classification, we're gonna perform sentiment analysis on the movie dataset. We use the NTLK, NLTK movie reviews corpus. So we lowercase tokenize and remove stop words and clean up punctuation using NLTK's tokenizer. And then we use TF-IDF vectorizer to convert text to sparse matrix using both unigrams and bigrams capped at 5,000 features. And then we split into training and test sets and train a logistic regression classifier with liblinear solver. And after that, we're going to print the accuracy and classification report. And then we're going to test it on 3 sample new reviews. And we're going to see how it gives the sentiment and the predicted scores. So these are the precision, recall, and F1 and support scores as well as accuracy. So these were the sample inputs that we have given. So these are the confidence and the predictive sentiment. for our sample test cases. Next, we're gonna move on to image classification. Here we are gonna use the CIFAR10 data set. First, we're gonna normalize the data set, therefore using mean and standard values, and then we're gonna load train test splits with torchvision.dataset.cifr10. So basically, we build a simple CNN with 3 convolution layers and 3 dense layers. It includes max pooling and dropout to improve generalization. And then we use Adam optimizer and cross entropy loss. And we also log loss and accuracy per epoch and visualize the training curves. So we evaluate on the test set and print per class accuracy, example like cat or car. It gives great insights into classes performance. And then we show 8 test images with both ground truth and predicted labels. So this wraps up the supervised vision pipeline in PyTorch. So this the training loss over the epoch and training accuracy over the epoch. It's a good sign. It's kind of improving. So here you can see the ground truth and the predicted value of the by our model. So the first one says it's cat and it's a cat. The second one is a sheep and it's a sheep. Third one is also a sheep and it's sheep. Fourth one is kind of better jet, but it's fine. The ground truth, as per the dataset, is plain, so it is a plane. And the next one is frog. This is also frog, and this image is of car, and the predicted is also car. So it's this accuracy per class with which is predicted. And next, moving on to time series analysis. Here we're gonna use CO2 data. We're gonna load the lower CO2 readings from stats model and resample to monthly average, and then we interpolate missing values. We then use seasonal decomposition to split the time series into trend, seasonal, and residual components. This is crucial for understanding the structure. And then we fit a ARIMA with a 5,1,0 to train the model on training data and predict future CO2 levels. We also compute RMSC, RMSC, and MSC for evaluation. And then after that, we're going to forecast it for the next 12 months ahead and plot the predictions along the actual data. So this monthly low CO2 levels um, with a gap of a decade timeline. These are the SERMA results, and this prediction forecast values for the next 12 months. So next we are gonna discuss about audio data. So we're gonna use the yes no data set, which contains spoken recordings of people saying yes or no in different patterns. We use matplotlib to plot the waveform and icons audio kit to play the sample sound. So we also generate a spectrogram using torch.audio.transformers.mel spectrogram and convert it to decibels with amplitude. So and then we're gonna display the waveforms for few audio files. So this is the waveform for no, and then moving on. Next we are gonna load MNIST data. We're gonna use TensorFlow for it. We load 6,000 training and 10,000 test images of handwritten digits. We're gonna normalize images from 0 to 255 to 0 and 1 and batch them, shuffle and prefetch the dataset for performance. We display 5 example digits from the training set to verify the pipeline, and then we use 2 convolution predict the test images and show predicted labels alongside the true ones. So these are the labels after training. Here we can see that the gap is less, so it's not overfitting or underfitting. So this is the true and the predicted values. True is 0, predicted is 0, so it's 8 and predicted is 8. Here in this sample, all the predicted values matches with the true values, indicating that the model is performing good. Next, we're gonna deal with the video classification using R3D18 on a sample video. We open a sample video, which is a .mp4 file in this case, and extract 16 RGB frames and prepare them for the 3D CNN model. We resize, crop, and normalize frames and convert them to 5D tensor, which is 1 C, T, H, and W. So we load R3D18 from Torch Vision and get logics. We then apply softmax to convert to probabilities. After that, we map indices to class names using kinetics.txt, which has around 400 labels, and display the top 5 predicted actions. We extract the middle video frame, which is around frame 8, and reverse the normalization and plot it. So here we can see that the top 5 predictions are driving car, which is kind of label picked from that one of the